Another thing that I really wish was actually done in the curriculum before this is compound interest. And nobody, almost nobody, ever comes into this course understanding compound interest at any level. It's criminal, because you kind of need, first of all, it's really kind of important financially, right? And you all are eventually going to start making money, right? Many of you already are, okay? And hopefully in the future you'll be making a lot more, even though some of you look pretty rich. I'm envious, but okay? I know, it's all an act, right? And those of you who look really poor and tattered like me, you know, are probably the ones that are really rich, right? I don't know. Okay, now, for financial considerations, it's extraordinarily important to understand compound interest. You have courses that are related to personal finance and stuff. You have to take those courses in high school, and you still don't understand compound interest because the people in those courses don't have enough mathematical background to understand compound interest, and nobody understands it. Duh. Okay, well, off the soapbox again. Now, let's say you make an investment, and the value of your investment is $1,000 times E to the 0.03 T. Okay? Now, talk later. You know, we don't have time today to explain where that could come from, and it's a little bit of an involved process, and we probably won't get that even before the test, but we're going to apply the inverse function thing to find out when you have $2,000. Okay? So we want to solve P of t equals $2,000. Okay? Now this is related to a graph. Okay? The graph of the exponential function looks exactly like the graph of the 2 to the x function. Every exponential function has a graph that looks exactly like the graph of 2 to the x. Okay? But the labeling of this axis will be different. Okay? So where the 2 to the x has a 1, the e to the x function would have a 0.7. Close to 0.7. Okay? I think it runs maybe 0.69 something. And the e to the 0.03 x function, or the 0.03 t function, would then be expanded in the x direction by a factor of 33 1/3. 1 divided by 0.03. Okay? Okay, you don't need to remember that right now. I'm just telling you that this is all related to what we've learned about transforming functions. There's a fourth transformation, which is a horizontal compression, where we squeeze things in this way or expand them out this way. Okay? In any case, you can visualize this question in terms of a exponential graph. Every exponential graph looks like this. If the coefficient here is positive, if it was negative, you'd have, you know, this kind of a graph. If you just label the axes correctly. Okay? So, okay. So here's your P of t function. Here's t. Right? What is P of 0? Somebody tell me what P of 0 is.
What do you mean, just like on the t-axis of 0?
Take this thing here and plug in 0 for t. What do you get? Where do you see a t in this expression?
Would be 0.03.
Got 0.03 times t. If t is 0, that would give you,
There.
so it would give you 1,000 times e to the 0, right? What's 1,000 times e to the 0?
1,000.
It's 1,000 because any number to the 0 is 1, right? So, it's $1,000, right? Well, that tells us that your scale of the graph is going to have $1,000 right here, right? Okay. Now, I said we're going to solve P of t equals 2,000. I'm going to change that since we haven't done anything with it. I'm going to make it 8,000. Okay? Now, according to this graph, you don't know what the t-scale is, and we're not really going to talk about that, but I want the picture from the graph, and then we're going to solve the equation using the inverse function property, okay? And you're going to calculate it with your calculator, and you're going to come out with something like 100 years. Takes a while. That's like a continuously compounded 3% interest. That's what that would be. Relates to interest and stuff in a way that will work out. Okay, where's 8,000 on this graph? Where's P of t equals 8,000? Well, that's just how you solve an equation or estimate a solution by looking at the graph. You come up here to 8,000 because P of t is this, right? And this has to be 8,000. Well, if that's 1,000, then that's about twice as far as that's 2,000. Now, if you double this, you get 4,000, and then double this, you get 8,000. So let's say here's 8,000, right? And what's your solution? Whatever this t is. And we eventually, and fairly soon after the end of the month, which is coming up faster than you wanted to, we'll understand all the details of this, okay? Again, it's kind of important, okay? Even if you don't work in finance, you will have money, hopefully a reasonably good amount of money, and you might even want to invest it, so when you get to my age, it'll be worth something. I should have started earlier, but so be it. Okay, you want to start early on that too, okay? Okay, so here's what you want to find, the value of t at this point. Now, we're going to solve the equation. Okay, the equation is P of t equals 8,000. Well, that means 1,000 times e to the 0.03t equals 8,000. Right? So what would you do? What's the first thing you would do in attempting to solve this equation? There's really only one step that you would have any clue how to take that would at all be helpful. Any? One really obvious thing you can do with this equation. There's something else that you would know how to do but it wouldn't necessarily be that helpful. What's the most obvious thing? I'm sorry?
Divide by 1,000.
Yeah, and don't subtract 1,000. I still see that at this point of the course, in a typical pre-calculus course, right? If you subtract 1,000 from this, you don't end up with e to the 0.03t, but if you divide by 1,000, you do. So, you do this, you get e to the 0.03t equals 8. Okay? Now what do? Well, this is the one that's probably pretty unfamiliar to you. If it was t squared equals 8, what would you do?
Take the
You take the square root of both sides. How's the square root related to the squaring function? They're inverse functions. What's inverse to the exponential function? The natural log function. So we apply the inverse function, natural log of e to the 0.03t. And we do this, of course, to both sides, equals the natural log of 8. Okay? When we apply the inverse function, we end up with just 0.03t equals the natural log of 8. Natural log of 8 is a little more than 2. It's like 2.2 maybe. Okay? So I'm just kind of guessing 2.2, 2.1 maybe. Probably around 2.1, 2.2, somewhere in that range. Okay? Anybody got it?
2.07.
Huh?
2.07.
Yeah, it's closer to 2.1. I kind of thought it was. Thought I'd be at least a little inaccurate. Okay. So the t is about 70. If you divide 21 by 3, you get 7. You know, just think about this. I said around 100 years, more like 70, okay? So it's pretty easy to do this if you understand things like when you solve x squared equals something, you apply the inverse function, the square root to both sides, you're using an inverse function. Here, you're using an inverse function in the same way, okay? So I'm going to give you some equations to solve in this manner, okay? I'll repeat the rules for you, but if you know that much, you already know more than a lot of people come out of a pre-calculus course with, okay? Not that it's going to be enough, but you know, we want to understand these connections, okay?